back. We will continue the session. So discussing about this simple interest calculation part. So here this time value of money actually, I take the discussion based on this simple interest. This is called future value interest factors. So here you can see simple interest calculation equation is simple interest, how you can find principal multiplied by interest rate multiplied by time period. So here you can see this is 1,000 rupees principal and rate of interest, annual rate of interest 0.07. So years, 2 years, so 140. So this can be, you can take it, this future value interest factor actually from the table also. Right? So I actually send the table for future value calculation and etc. Today morning only uploaded. You can upload the tables related to see these calculation. You can either use the formula based or you can go with the time value table to take the factors for calculation part. So here at the end, you can see we deposited 1,000, interest total 140. So this money converted into 1,140 after 2 years of that. Basically, that is called simple interest. I don't want to explain much. You are familiar to this basic concept. So moving from that, if you go for, as I explained, this future value interest factor table, that tables are prepared based on the, is that table prepared. 1 plus I rate of interest per 10. Right? This space is only, this tables are prepared. So if I saw the table actually, I uploaded all the table, please download all the table, relevant tables. So how the tables are there, you can see the tables. Right. You can see, right? This is the table. So here, rate of interest I1, you can see top future value equal to 1 plus I power n. But I put the formula, the tables calculated with the different rate of interest with the time period in 1 year, 2 years. But you can see these are standard tables. Tables are not always available with, if you have a 4.5 years, you don't have a table. Then you have to familiar with formula for that type of calculation. Say, if you, sometimes are there 4%, 4.5, 3.5, 5%. But sometimes standard tables are not available, then you can use it for, formula in that cases. So I uploaded all related tables, right? One will learn all the concept today. There are 6 tables are uploaded connecting with what we are going to discuss. Okay, right. So moving to our discussion based on this. Now upper slides you can see. So here you can see this future value interest factor. So you can take it from 7% 2 years from the table. That is what I show you the equation and the table you can do it. If the tables are not available, standard tables, that calculations are not given in the table, you can always familiar with the equation. Then you can go for either table or equation for your calculation. Moving from this single value calculation, as I explained with this, you can see here. So this Jane places 800 rupees in the saving account, paying 6% interest compounded annual. Now we are going with this calculation based on the compound interest rate calculation. How every after depositing your money plus interest is actually get into next period to as a investment, and that grows again with the interest. What is happening here? This today's principal. Then at the end of the time, you plus interest. Interest plus principal goes to next year compounding. So that compounded value, you interest is adding with that compounded value. Accordingly, principal including the interest that continuously deposited over the time. So that is called actually this compounded interest rates. So here you can see in case of this compound interest rate, if Jane places 800 rupees in a saving account, 6% interest rate compounded annual. So she wants to know how much money will be in the account at the end of 5 years. So I use the same formula, P naught principal value, or we can use the term present value, today's value, multiplied by 1 plus I is interest rate, that is 0.06. Then N is power N is 5 years. So if you go to the table, as I show the table will show this value. Future value interest factor 5 years at its percentage. The value is showing as 1.3382 in the table also. Or you can use it this same calculator. Based on the calculator, if you calculate this equation, that also shows the same answer. So multiplying that is called your future value. Similarly, you can say, I put an example, Amir invests 1,000 today, he will receive 3,000 8 years of time. What is the implied interest rate? Now you can see this question is connecting the same principle what we learned, but you can see the question is not, I am not asking the future value. The question is asking about and the equation, anything we can ask, right? You can see interest rate of interest or time period or future value, anything can be connected. So here, Jamir invests 1,000 rupees today. He will receive 3,000 in 8 years of time. What is the implied interest rate? At which rate of interest in 8 years of time, this 1,000 rupees converted into 3,000? Can you try yourself and find the answer? I will give you maybe 3 minutes of time. Can you try and update the answer in the chat box? Anyone, please do it. You can use your calculators. Please use the calculator. What is the answer? Put it in the chat box, your answer. 14.72. Okay, one Madhushan put the answer. Others? Answer is correct actually. 14.72. Others, how to do that? Now if I put it in the chat box, the answer actually, how you can do it. So here actually, I will take this slide and see. I will add new slide and I will do it, then easy for you, right? I will name the slide and then I will do it. With the insert new slide. Right. Here you can see what we need to do here. This is future value equal to, right? Today's value, present value, 1 plus I power n, right? 1 plus I power n. Right? Calculator, you can use the power sign this way, power n. So if you take 3000 is the future value, present value is 1000, 1 plus 0.06 power 5. Power 5. Now you can see, right? So this 3000, then you can bring this 1000, this equation, this is multiplication this side. So if you bring this side, 3000 divided by 1000, right? That is what the mathematical calculation, right? Multiplication, this side comes, division, 1000 equal to 1.06 power 5. You can use the calculator and calculate how much this, not, but we need to, I is, we don't know. So we need to put I here, right? 1 plus I, this is power 8, okay? 8 is, right. So 1 plus 8. Now we know this 1 plus I one plus I 8. So how you can write this actually? 1 plus I 8. One plus I power 8. Power 8. So here 3 equal to, right? 1 plus I power 8. So how we can write this actually? This 1 plus I power 8, 3 equal to this part. How we can write this actually? We can write like this way, right? Mathematically, this is goes with the power. Then what is the meaning of this actually? You can write. But 3, 1 upon 8, right? How you need to write? 3 power 1 divided by 8, okay, equal to 1 plus I. 1 plus I. Now you can actually solve this, right? Easily, everyone can understand. You can see this is power 8. How we need to bring it here? 3 power 1 over 8. So that is mathematically, that is the solving method. So you can see this 1 plus I. Now you know, you use the calculator, find this value. If you find this value, that is 1.1472. It comes as 1.1472. So then we know this is 1 plus I. So this is now this one coming here minus 1. So it becomes actually I become 14.72%. Is clear, everyone, how to do this? Clear, right?
Yes, ma'am.
Yes.
Right. So we can move to the next part here. You can see here. So this is actually what we have learned. So this graphical representation on what we have learned. Okay. So graphical representation, actually, you can see accordingly. Years to 20 years, money values are different. So if you take the future value of money, you can see with the rate of interest. So higher the rate of interest, again, you have a relationship you can observe. The future value of money is greater. So you can see the direct relationship. If the higher interest rate, higher future value, the time period, higher time period, the future value of money is greater. So we bring the relationship and the things based on the compound interest calculation based on future values. Now we need to see actually this compound interest calculation and etc. based on this money connecting with the frequency of compounding rate of interest. So the meaning of this frequency means, so whether in the future value money is compounded every day, or money is compounded for a week, or monthly, or quarterly, or semi-annually, how it is compounding. So frequency can differ. So accordingly, that is what you know, you have experience when we go for FDs in the banks. They are asking whether you want to put for quarterly interest or semi-annual or annual. So now we can see the magic of this compound interest, the power of this magic on the compound based on the, frequencies. So there is an impact due to the frequencies with the magic on the compound values, right? That is what this formula is explaining. So either whatever the frequency period, compounding. So you need to use this interest rate is normally stated in any economy annual. So we need to divide it by this. Now M is standing for the number of compounding period within the year. Say if it is semi-annually, twice, 2 times. If it is quarterly, the quarter is 4 times in a particular year. So then you need to have a concern to take it divided by a quarterly interest or semi-annual interest by dividing by M. Then you need to take number of periods, that is multiplication by M. So other than that, the same equation what we learned, but these two, I and N is changed due to this frequency. That is what here I is the annual interest rate. This is present value or today's value or principal. This is the future value. Now, if we take the example with the frequency and the relationship with the future value, how it's changed, you can see here. So here I put, Yuli Miller has 1,000 rupees to invest for 2 years at an annual interest rate of 12%. So if we have a frequency annual at 12% for 2 years, that becomes after 2 years, 1,254.40 cents. But if you take semi-annual interest rate, then I give this is 6% semi-annual. Your frequency, number of period bring into 2 years into 2, 4 semi-annual interest payment. So it becomes 2 into 2, 4. You can see the value increases to 1,262.48 cents. Then if we move to quarterly, further it increases. You can see frequency increases monthly to daily, I considered at 365. Then it becomes 1272.20 cents. So it clearly explaining that frequency on this either annual to semi-annual to quarterly to monthly to daily, that value, total future value increases. That is that you can see the magic. We never see it and we never feel it when we make decision in the banks with our money on these frequencies. If the interest rate for a particular year is same, if interest rate change, this cannot be the same. But interest rate is stable for next 6 months. Then if we go for monthly payment or monthly, put it to monthly is a better option for us. We can get more value. That impact you can see. Why it happens, you can see rate of interest, effective rate of interest is different from the nominal interest rates. So that is the reason actually that influence is there. So you can see that I didn't explain this continuous part. So when we take other than this daily interest rates, there is a possibility in theoretically we can say every nanosecond this money is actually money values are increasing. Every nanoseconds money value is increasing. So if the money value increases every nanoseconds, right, you can see that the value is coming. So the meaning of this continuous compounding actually, this is not based on the what we learned previous concept. This is different actually. This is actually in mathematical, mathematician define this continuously. If every nanosecond money have a ability to concern, how that growth can be happening, that growth is estimated by this mathematician as a exponential growth. They use the word actually that is called, we learned the concept as exponential growth. Okay, this growth is called exponential growth. You might heard about the word exponentially growing. What is the meaning of that actually? Continuous compounding forever, money can have ability to grow, or a specific period money have a growth. That every nanosecond that growth is how we can calculate that on average basis or compounded average basis. These growth rates are possible with the exponential way. What is that exponential growth that implied that? Mathematician define as a e to the power. Right? E stand for this exponentially growing. So that is what you can see. This continuous compounding equation joined with this exponential value. So basically for that compounding value is exponentially with your in n. That is called your total compounding factor for in case of continuous compounding. So always this E value is defined by mathematician as a constant value. That is 2.7183. This is the constant value. This exponential value is constant. That is defined as actually 2.7183. So if we take some example based on theoretically, this is also possible. So to find the value at end of 2 years, for the Fernando deposit 100 rupees. So paying the account by 8% annual interest, but that compounded continuously the interest rate. In that case, how we can calculate this deposit's future value? You can say 100 rupees. E to the power interest rate is 8. Time period is n. E stand for the constant value of 2.7183. This is 8 multiplied by 0.16. So if you calculate the value, that becomes 117.35. So this is continuously compound. So we learned the frequencies from continuously to whatever the different frequencies and the impacts are there and future values are there, we can see. Okay. So why the differences exist actually, the future value, this frequency is the matter, why the interest rate is changed. Actually, there is a difference always between the nominal interest rates and the effective annual interest rates. Nominal interest rates are normally called as we learned, that is in the any economy, the central banks announce the interest rate of interest that is normally called as the nominal interest rates. Banks are given that nominal interest rate for us. This is the interest rate today for the bank, right? So that is, they depend on the money supply and the demand for money in the financial system in say Central Bank of Sri Lanka. Observe the money supply and demand process that determined based on the market condition of the supply of money and the demand for money, that normally nominal interest rates are decided and Central Bank announced as a nominal interest rate for any economy. Okay. So these nominal interest rates always include the rate of inflation, how much exists in the particular economy. That is including the inflation rate. Finally, nominal interest rate say 10%. Oh, now banks are announced as 8%. Now in Sri Lanka, very low due to the inflation goes down, your interest rate goes down. Right? That is what you can see with the economic principle. So now we may have 5 to 6%. Right? It comes down to 6%. So that is nominal interest rate. But effective interest rate is different from nominal interest rate. What is the effective interest rate? That frequencies are effect on these rates, nominal interest rate, that is called as effective interest rate. This effective annual interest rate can be calculated based on compounding nature of this interest rate. 1 plus I divided by m power m, this minus 1, enter this equation minus 1 is the effective annual interest rate. So this effective annual interest rate is different. Due to that, you can see, as I explained previous example, the future values are different. So that is what you can see here. If take the example to find out the effective interest rates related with 8% nominal rate of interest, compounded either annually, semi-annually, quarterly. I take 3 frequencies. So in case of annual, we have a nominal 8%. 1 plus this I divided by m minus 1, you can see that is equal to 8%. Since, you know, nominal and these frequencies are no matter, both are annual, so 8%. But frequency change to semi-annual, you can see. We take the nominal 8% divided by 2 into, you can see this 1 multiplied by this 2, m is now 2, semi-annual is 2 periods. So minus 1. So that becomes now what is the multiplication here? It comes as 1 plus this 1.0816. So if we deduct this minus 1, 8.16 is the, you can see the interest rates. In case of quarterly, you can see quarterly payments or quarterly interest rate frequencies. It brings it to 8.24%, the annual interest rates. Due to that, you can see your future values are increases due to this. Nature of the frequencies are impact on your values. That is called your effective interest rates are different from your nominal interest rates always. Okay, so I think it's very clear to you what I explained with the influence on these frequencies or matters with the interest rates. So we can move to, before move to annuity concept, take one simple example on what we learned with the compound interest area with the bank savings. With the exercise, I send the exercise page. You can move to the exercise page with that. So here you can see, I share this exercise. Already I uploaded these exercises in the Word document. So if we take the numerical example, right, here you can see question 1, you try at home, right? That is easy. We can take question number 2. So question number 2, Mala has 10,000 rupees that she can deposit in any 3 saving accounts for 3-year period. Bank A compounds interest on annual basis. Bank B compound interest twice each year. Bank C compound interest each quarter. All 3 banks have a stated annual interest rate of 4%. What amount would Mala have at the end of the 3rd year, leaving all interest paid on deposit in each bank? Mala deposited 10,000 in each bank. What is the Mala's future values in all 3 banks is the first question. Second question, what effective annual interest rate would she earn in each of the bank A, B, and C? On the basis of your findings in part A and B, which bank should Mala deal with and what is the reason for that? Okay, say part D, go for the 4th bank D, give a 4% stated interest, compound interest continuously. How much would Mala have at the end of 3rd year? Does this alternative change your recommendation on part C and explain why or why not? So these are the concepts actually we learned now, we discussed now. Can you try the answers on this numerical example on, say, practical A, if you can apply this to see the difference on managing your personal money. This is applicable to banks to handle their monies as well, cash flows as well. So can you try this and update the answers in the chat box? Then we can move to the second concept of annuity. Everyone, please, I don't know, this is online class. Please try yourself and update the answers. So don't waste the time since you know you are familiar to the finance by doing on. By listening, you can't do it for exams. So please, doing yourself, that would be helpful for your examination as well. You have to do and see, right? This is the quantitative subjects. Please do and update the answer in the chat box. Right, students? I think that there are all the answers are correct here. So your first question, part A, 11,248 or 240, even 250 you can put. Bank B give 11,261 to 62, 63, okay. That bank C can be 11,268 to 11,270 is okay. Right? That is the answer for first question. Coming to part B, what is the effective annual interest rate? All of you put the correct answers. Bank A 4, Bank B 4.04, Bank C goes for 4.06. Okay. Then part C, definitely Bank C is the answer. Then you need to write in under that why, that is frequency different. So quarterly is the higher frequency that generate more interest rate that finally gives the more future value. So recommended for the bank C for deposit that money. Then if you move to continuously compounding bank, we can see that 11,275 nearly. The continuous compounding equation, if you use it, the value is according to continuous compounding. Yes, to 11,274.98 or 97 or 75. Any closer values are okay. So you have to then recommend the bank D. There's no complicated question, this one. This question is directly based on the principles or concepts of what we learned. I have prepared the exercise. So all the answers are correct, right? So I can move to the next discussion from this to go for the other concept related to future value. So then we can move to the future value annuity concept. As I explained, these annuity values are connecting with the periodic cash flows, equal amount of cash flows over the time, right? So this future value of annuity is you have known period. The annuity is very, important concept in all financial corporations or company decision making. So there are oftenly they might expose to this type of decision-making process with the annuity principle. So annuity principle is, that trend is very important for companies' perspective. When we take this annuity principle, actually, this is annuity is called the cash flow is equal amount of periodic cash flow for specific time, right? So if we take this annuity concept, you can have a understanding that with the real life practice or real life examples. So this future value annuities are connecting with this insurance premium. We always go for our life insurance with the companies with periodic payment for our 20 years or until our 70 years or 65 years. We have a specific time period with the deposits with the insurance companies. We are paying our life insurance is a good example for future value annuities. So life insurance companies calculations and all are connecting with this, what we are learning, this equation or formula related to this premium. Or maybe you might have a recurring deposit accounts for your child educations in the future. That is also connecting with the specific amount in the banks. You get the order to the bank from your salary, 20,000 per month, fixed orders. So that is also connecting with this. You can see this future value of annuity concept for next 10 years. So you can understand that importance on this annuity principle in the real life principle. Real life, this is very practical concept. Practically, we are doing ourselves. That is connected with actually as a future value of an annuity. This annuity principle or annuity cash flows can be divided into two categories, two types. One is ordinary annuity, and the one is annuity due. So I send the tables also, two tables I send. Future value ordinary annuity table, future value annuity due table. What is the difference? Normally, if I say annuity, that stands for ordinary annuity. Okay, so if I normally say, if we put as annuity, that principle is called ordinary annuity. So that other, if we, in case of cash flows are connected with the due, it should be clearly mentioned as annuity due. Future value, annuity due. So what is the difference? If normally for businesses or companies, cash flows are occurs or either payment or receive the cash flows at the end of the year or end of the period. So that is called cash flows occurs at the end of the period is called ordinary item. This is common. This is generally most of the payment and receivables or receive the cash flows at the end. So that is what annuity stand for, this ordinary annuity. There are cases we need to pay the cashes or payment may be in the beginning of the year or returns income we can receive in the beginning of the year. So in the cash flows occurs a payment or receipt at the beginning of the beginning of the accounting period, then that is called annuity due. So that is what we can see for a company, they have an accounting period. Accounting period can be started from say April 1st to March 31st. Or maybe January 1st to December 31st. There are two types of accounting period. Normally companies are operating with the cash flows. If they are receiving either March 31st or maybe December 31st, those are end of the cash flows occurs. That is called ordinary annuity. If they are received at January 1st or April 1st, that cash flows are beginning of the each period. That is annuity due. So it's very clear. So these cash flows occurs differently, then your future value annuity values are different. So that is what I put the calculation part here, you can see. In case of our general application is ordinary case, ordinary annuity. So if you receive end of the period year 1, year 2, year 3, say December 31st or March 31st, equal amount annuity cash flows are always equal. This is also 100 definitely. All are 100 rupee cash flows, equal cash flows if you receive. For this 100 rupees, what is the total annuity factor or annuity value you received? That is called future value of annuity. So if we take the first 100, that take the interest rate at the end. So end of the year 2, end of the year 3, 2 years earn the interest. The second 100, only 1 year interest. Third, it received at the end of the year, there is no interest at the third year. Once we are taking the year 3, what is this cash flows? So that is what future value of ordinary annuity equation is generated based on this principle what I explained. You can see cash flows multiplied by, this is the equation, 1 plus I power n minus 1 divided by interest rate. Right? Or this formula is applicable in the future value annuity interest factor table. And you can go with the ordinary annuity table and you can see that. Actually, I send the table, you can see the future value ordinary table there. So here you can see here, this table is related with, if I take the table, right? Present value ordinary table, then we can have a future value. This is annuity due. This is present value annuity due. This table is, you can see, 1 plus in minus 1 divided by I. Same equation what I showed. So future value annuity interest factor calculated. Say example, 7% for 5 years, 5.7507. Okay, this is ordinary annuity given. So similarly, you can see future value annuity due table give a 7% 5 years, different value you can see. That is 6.1533 more value. You can see that. Right, that formula is different. So we coming to our equation and our discussion with the slides now. You can see here, right, sharing that. Stop this, move to the slide. So if I go with the slide, so we can see that this is the equation, that table is generated and that factor is given 5.7501. So if you use the calculator, we can get that factor. So you can multiply that future value annuity factor, interest factor with the cash flows given. You can see after 5 years how much of annuity cash flows converted there. So that is what, if you go with the table, you can take the table value particular interest rate with the time period. you can take the table value and you can calculate the ordinary annuity, how much of future value generated by the cash flows. So here, what is happening here, I explain that mechanism on this calculation part you can see here. So 7%. So 3 years, if you are receiving cash 1,000 at the end of year 1, year 2, second 1,000, year 3, third 1,000 rupees if you are receiving cash flows occurs at the end of the period. So how the future value annuity happening you can see. This first 1,000, take the interest for 2 years, 1 plus interest at 0.707, 2 years factor. So that becomes actually thousand to second 1,000 as it is 1,000 rupees since it received at the end of the year. So you can say that. So here altogether we are earning 3,215. If we 7%, 3 years 1,000 rupees, how much converted into at the end of the year 3 is 3,250. But we can use the table value. Come to the ordinary annuity. Okay, that is one way. Oh, other way what we can do here, we can see the connectivity on this future value compound interest calculation, what we learned, future value interest factor, how the tables are connected with the future value ordinary annuity tables. How, if you are invested 1,000 rupees for 3 years at 7%, future value interest factor table shows the future value for that is 1.145. So if you invested 1,000 rupees for 1 year, future value interest factor table shows 1.07. Right? Today's value, future value is 1. So you can see that is accordingly that factor accumulated, adding all, that is what cumulatively that factors are adding. That shows us 7%, 3 years annuity factor, future value interest annuity factor is 3.215. That is what we take that factor and multiply by this 1,000, and that become totally 3,215 as based on this concept future value of annuity. Is it clear, right? Is it any doubt? Manora, is it clear? Ordinary annuity, Sabandi?
Yes, madam.
Okay. Right. Then moving to the other concept is annuity due. If we take the annuity due, what happened? We are receiving our cash flows or paying our payments on the beginning of the time. Beginning means you start with January or you are paying on April, if based on the accounting year of the company. Then what happened? This 100 earlier we are receiving at the end, December or March 31st. Now we are getting at January 1st. So during this 1 year, that earns the interest. So 1 year gap is there to beginning to end. Due to that, so first, this 100 cash flows receive 3 years interest. Second 100 take 2 years interest. Third 100 take actually 1 year interest. In third year beginning, that cash flows are received or paid. So annuity due, each cash flows, periodic cash flows get additional 1 year of interest compared to the ordinary annuity. Due to that, annuity due formula is always adding this way. You can see this is 1 plus I. 1 plus I n minus I. This is the ordinary annuity equation. 1 plus I additionally, each periodic cash flows are added. That is what here that we can go with the ordinary annuity table with the 1 plus I, or directly you can go to due table and you can get this value I show the due table already show you. That table is calculated with this formula. You can directly collect it from the due table. Right? Then you can calculate what is the future value based on annuity dues, what is the future value of the cash flows. So here, if I take that mechanical process on that, what happened here, you can see from the previous example with the ordinary annuity, first 1,000 goes for 3-year interest, here 3 years. Second 1,000 go for beginning of the year received due to that 2 years. Third year, you receive at the beginning, you get 1 year interest. Due to that, so your total future value annuity due cash flows are converted after 3 years as 3,440. Or you can go to the table, annuity due table, that will shows 3.44 as the factor, this annuity due table, and multiply by that, and you can get the answer. Or you can go with even ordinary annuity table, and then you can multiply it by the additional factor 1 plus I, and you can get this value. So now it's clear with the ordinary annuity due to connectivity on the cash flows received differently, how the money value change based on periodic payments or annuity cash flows. So that is called annuity due or ordinary annuity in case of future values. So it is very clear always future value of annuity is greater than the future value of ordinary annuity. If you are receiving the cash flows early, give more value to the company. If you are paying, that is actually a disadvantage to the company. Is it clear, students, what I explained as a annuity, ordinary annuity and annuity due? Then what I can take, actually, there is one example with the future value. Quickly, I think we finish that and we can move that. So I think that exercise with the future value, present value, take that. Right. So here you can take this future value question. So question number 4, here you can see Rama wishes to choose better of 2 equally costly cash flow streams, annuity X and annuity Y. X is an annuity due with a cash inflow of 9,000, but here amount is different for 2 annuities, right? That is, I didn't discuss, but this answer you can see that due to that the changes can happen, not the equal amount. Okay, so X annuity due with the 9,000 for each of 6 years. Y is the ordinary annuity. This is annuity due, this is ordinary annuity. That is also cash inflow, but this is 10,000 of each 6 years. So assume Rama can earn 15% on his investment. Part A, on a purely subjective basis, which annuity do you think is more attractive and why? Before we calculated, right? We think which one would be more attractive and which one give a more value to us, right? So if we take, this is 9,000, this is 10,000 and 6 years. So we, without calculation, we can say ordinary annuity of this 10,000 with the 6 years would better option, right? Subjective decision, not objectively. We use scientific logic on this decision. If we take our valuation part, find the future value at the end of year for both annuity X and annuity Y, both annuities. And you need to see, using the finding, which annuity is more attractive comparatively after scientifically you calculate. So can you try the answer for annuity X and annuity Y? What is the value of annuity X and annuity Y with the given exam? Can you try? I will give you 5 minutes. Can you try the answers? Others, please calculate whether the same answer is coming. X is X and Y. Any others? Is it the answer correct? Person, please check. Once I calculated little bit more. 15%, 6 years you take ordinary annuity and the annuity due. Bandara, what is your answer? Can you put the answer in the chat box? X is wrong. Yes. Then Y should be wrong now. Yes, Madhusha. Right. Any others? Nayanadara. Ambi. Anupama. See, what is your answers? Rihan, what is your answer? Okay. Yes, X should be correct now. Y should be already, your answer is correct. Right. Others, please check. So in case of X and Y, right? So you can see the answer here. Right. So future value ordinary annuity, right? So I take the equation directly and use the calculator and calculate it. You can see. So 1 plus I 15, 6 minus 1. So here divided by 0.15, again I, right? So it becomes 87,537.38. Here cash flow 10,000 in case of Y. In case of X annuity due, so if we use the annuity due equation, so cash flow is only 9,000. So 15% on 6 years replace the numbers. So you can see it is nearly factor value becomes 10.06675 as a factor value comes. You can go to the table, even you can take that is the factor value connecting factor should be comes. So here factor value must be 8.7537. Closer value should be come in the table. So then finally, the final answer comes as 90,602. So when we see actually, this is 10,000 for 6 years, then we see as a higher value for this, even the 10,000 compared to 9,000 greater value. But you can see always due is greater, even the periodic cash flows are different. This due to this due, they are getting in early. So cumulative factor is annuity factor is greater. So your total value is great. So then you need to explain that cash flows occurs in the beginning. So due to that, annuity X is annuity due, bring the more value compared to ordinary annuity. Okay. So that is what you have to explain. Is clear what we have discussed? Right? So I think I have completed with the future value concepts, all future values related with the cash flows. So yourself, you can do some more additional exercises. I will upload maybe before next week some few more additional exercises, or you can check any textbooks, any financial management books. All the books are having this topic and the exercises are there. For your practice, you can do more if you want to get more practice on this. Okay. So this is future value. Similarly, we need to learn with the present values as well. So in case of present values, we will discuss. I think I can give you some break now, lunch break. So go for 15 minutes break. Then we can continue the session with the present values. Okay? Right. Take 15 minutes for lunch break. Right. Hope everyone is here. Madhushani, are you here?
Yes, madam, I'm here.
Okay, right. So we can go to the second other concept under the time value of money, present value. Similar to future value, we need to connect with the cash flows. If it is lump sum or either annuity or perpetual cash flows are connecting there. Same with the present value as well. So as I explained earlier, present value is the today's value, right? So that is what we define that monetary unit you receive now is worth more than receive in future date. So here this present value is the current rupee value of the future cash flows. So if you are invested today, we can get the cash flow maybe 50,000 rupees next year. So what is that 50,000 rupees today is called present value of the money. So if we take the today's value, that is called the present value. In case of single amount, right? The process of finding present value is often referred to, as I explained, with the discounting the cash flows. So in the present value concept, it is very important in all financial decisions. All the decisions are rely on this present value basis, right? Since cash flows we are forecasted for future, but we need to make decision today. Due to that predicted cash flows, and we need to evaluate in today's terms, and we see either we can accept this or we can reject these decisions and etc. based on this most of the time present values. That is what we use this discounting tool to take this. That is what in other terms we use to discounting these cash flows. Which rate we need to discount the cash flows? That is always opportunity cost for that cash flows or funds. That is what we consider as a rate of return we can select for take the present value. So that rate of return can be either interest rate or we normally common general term we use it as discount rate. Since that discount rate is discounting the cash flows, future cash flows into today's value. So we use the word discount rate. But this term is used in the different context based on that financial context. What is more appropriate, the term is actually used. Say here this is required rate of return. If you are invested in the company, you are the equity investor. If you hold the equity shares, so minimum return rate, required rate you are expecting from your investment, the equity investment. So that rate is called equity. This is required rate of returns. Or any investment, what is the minimum rate you are expecting? At least you need to reach that return rate. So you can use that rate as your discount factor or discounting rate. Or you raise the loan and you invested. Once you are raising the loan, you have a cost of the interest you have to pay for that loans. So the interest rate can be the cost of capital on that particular loan. Then that rate can be used as a discounting rate. Or any funds always have an alternative use. So opportunity cost is there. So that would be what would the opportunity cost of that rate can be considered as discounting rate. So it's very clear discounting rate should be decided by the particular company to discount the cash flows. But decision making on this discount factor is company need to see with the base which one more relevant discount rate for these cash flows to bring it to today's term. Accordingly, the company should first identify the discount factor for present value evaluation. Then company can evaluate. So what is the basic formula to present value? We are discounting the cash flows. So future cash flows, we are discounting today. That is what future value. That is what I put it here. The present value discount factor is this. How we can calculate the discount factor? 1 divided by 1 plus I. Here I use the term I for interest rate. It can be R, required rate of return, or cost of capital. So that is power n. 1 divided by 1 plus I. Here I use the term I for interest rate. It can be R, required rate of return or cost of capital. So that is power n. 1 divided by 1 plus I. Here I use the term I for interest rate. It can be R, required rate of return or cost of capital. So that is power n. So you can check the table as well. As I saw the table, there are some present value interest factor table. That is what I put this term. Present value interest factor table explaining at particular interest rate with the number of period, what is the today's factor, present value. So you can use the table or you can use this equation. Both are same, right? Future value into 1, future value divided by 1 plus I power n. So this is what simple lump sum cases you can calculate in the single cash flows based on this present value equation or present value, as I say, table. So here I consider two numerical example to understand this. This is very simple. Paul has an opportunity to receive 300 rupees 1 year from now. If we can earn 6% on his investment in the normal course of events, what is the amount of money he should pay now for this opportunity? So first is the present value of this 300 rupees at 6% rate. So then you need to see it's only time period for 1 year of time. So here only you can see this is also present value of 1,700. 8 years from now, but if the Mary's opportunity cost is 8%, what is the present values? Right? Can you try the answers for this quickly? Both answers, both examples, simple, but we need to do now. Try this. Use the present value factor table or equation. So if you take here, actually, you can see for this question, we need to calculate the present value equal to, in this question, future value is 300, right? So 1 over 1 divided by 1 plus I. 1 plus interest rate is given for you 6%, so 0.06. So you can find the answer, right? So answer must be 282.9. If we use the table, present value factor is given in the table as 0.943. Otherwise, you can multiply it by that factor. Similarly, same you can see here for this example 2. Present value equal to 1,700 rupees multiplied by 8% here. So you can see 1 divided by 1 plus 0.08. So if you calculate today's value for this, 918.46. Okay. Right, there's nothing much hard, right? Very simple equations, okay? Right, moving from this present value, now we can see the relationship with the present values, time period, and the interest rate. Opposite to future value, you can see the relationship. So here, if the time period is higher, your present value is lower. If the time period is lower, your present value is higher. You can see that. Say 20 years and 10 years, you can see. Depend on the interest rate. Higher the interest rate, your present value goes down. So inverse relationship between these interest rates and the present values, or time period and the present values of cash flows. So that is the relationship given in the table. Right, opposite to what we learned the future value. Now we move to similar to annuity. Annuity also same. There are periodic cash flows for specific time period. So this present value of ordinary annuity or this annuity concepts mainly applied in most of the company payments are at the end of the year always occurs. And they are maybe connecting with this periodic cash flows. So its application is there. We can take maybe a good example, our housing loans, mortgage loans, right? They give a table, what you are receiving the loans and etc. That is actually installment calculations are based on this present values of ordinary shares, ordinary annuities. So here, this is also similar to two types, ordinary annuity and annuity dues. So equation and formulas are there. I put the what do you call table, also I send it, you can check the values there. The formula is this in case of ordinary. If it is at the end of the cash flows occurs, cash flow divided by I multiplied by 1 minus 1 over 1 plus I n. Okay. So if you go to the present value interest factor annuity table, this is what the table will say. 1 minus 1, 1 plus IN divided by this I. This I put it here. This is the equation. So cash flow multiplied by this. Or this equation used to calculate this interest factor, annuity factor, and you can take it from the table. Similarly, what we have discussed up to now. So in case of ordinary annuity, take 1,000 rupees as an example. Cash flows occurs only at the end of the period. What happened for in case of 7% present value? So if we take the first, you can see this cash flows occurs at the end of the first year, right? End of the first year cash flows occurs. Only you need to bring it to today's value, 1 year discount. That is what first 1,000 discount by 1.07 power 1. This 1,000 year end of the year 2 cash flow discounted to 2 years to bring it to time 0. Always in cash flows or estimation part, today considered as a time as a 0. Right? We consider today is the time concept is 0, today's time. So in the time 0, to bring this value, 2 years you need to discount this 1,000 rupees. So that is what 1.07 discounted by divided by this 0.7 power 2. So if you are receiving at the end of the 3rd year, that cash flow occurs for after 3rd year in the future. If you want to see the today's value, you need to bring it in the today's value to time 0 value with the 1.07 power 3. You need to discount the factor. So if you are discounting, finally you can see present value of annuity for this is 2,624.32. So you can use the table, present value ordinary table, 7% 3, then factor is considered as 2.624. So then you can bring it to 2,624 multiplying by that annuity, present value, annuity interest factor. So this is related with, as I discussed earlier, similar to future value, present value, ordinary annuity. Due is different now. Due is 1 year difference is there due to that cash flows occurs in the beginning. Due to that, in case of present values, annuity dues, each annuity due, cash flow is discounted back 1 year less than an ordinary annuity. What is the meaning of that? Actually, so here you can see, here 1 minus this 1 divided by I multiplied by this 1 plus I. This is the equation. Or you can use this annuity table to present value annuity table 1 plus I. Or you can take the annuity due table directly and find the factor. So here what is happening for this 1,000 actually? This 1,000 received in the beginning of the year. 3,000s we are receiving. 1 is we are beginning. So time 0 we are getting. So 1,000 it always seems as same 1,000. Right? So here this says in the beginning of the first year. So we need to discount that to only 1 year. Right? To bring into time 0. So this cash flows occurs at the year 2 beginning. So we need to get this, bring into this into 2 years discounting. That is what I put it here. So if you're adding these cash flows, present value annuity due cash flows become 2,808.02. So if you take the annuity due table, you can see 2.808 is the annuity factor. You can multiply that directly. Or if you take the ordinary table, you need to use this value, 7% 3 years, 1 plus this 0.7. So it become 2,808. So it's very clear. You can use either annuity due table or ordinary annuity tables, or you can use the equation, but you can see in case of annuity due present value, or each cash flows are connected with 1 year less in discounting time. So now, similarly, you can see this is present value annuity due. Once we are calculating for same 2,624, here it become 2,808 due in case of due. Right. So other than this annuity concepts, present value annuity concepts, right? We have this perpetuity as well. What is the meaning of perpetual cash flows? Perpetuity in finance is forever cash flow. Forever means the perpetuity that is also annuity. In the annuity, time period is defined. Here, forever, unknown time period, indefinite time period. So it goes to infinity. That is called perpetual cash flows. So in that case, n is infinity, number of periods are infinity. How we can find this value for the company or any related cash flows? In that cases, there are kind of bonds are available in UK issued forever. That is the perpetual bonds or exist. There are very rarely, but application is there. Some projects are there, very long term, 50 years, then they considered for after some years as a perpetual cash flows for investment decision. So there are some real terms application are there. So accordingly, if you see this perpetual cash flows, you can see here. So present value, how we can calculate always. Cash flow divided by whatever opportunity cost for that particular funds. Here I considered interest rate. So cash flows divided by interest rate is the value forever if you receive 10,000 rupees each year. What is the value today? You need to take the 10,000 divided by this. Today's, what is the interest rate? You can calculate the perpetual cash flows. Okay, that is called perpetual cash flows. So last one is mixed stream of cash flows as I show the table. So you can be connecting with the future value of mixed stream of cash flows, cash inflow and outflow. Mixed stream means both are there, cash inflow and cash outflow. Or different amount of cash flows, not equal amount, cash flow amount are different. Either it can be related with future value concept or present value concept, this mixed stream of cash flows. Normally, this present value concept related with the mixed stream of cash flows are more applicable in financial decision making. All investment decision making by the companies are always based on this. What is the net present values on this mixed stream of cash inflows and outflows? And they calculate the NPVs. So that is called actually mixed stream of cash flows. So that NPV calculation, net present value calculation, I will discuss with you under the investment decision topic. So that application is there. Okay, that is called NPV calculation. Now, moving from that, we can go to the other concept under this time value of money is called loan amortization. So amortization is a other concept like annuity, perpetuity, the concept called amortization. What is this amortization? This is related with our debt. Once banks issuing these loans, they use the loan amortization. You all might be experienced with the housing loan. You get a amortization schedule, how to repay monthly from your salaries. All your loans, if you receive 6 million today from the National Savings Banks. So then interest rate is say 12%. So how you can repay for next 15 years your housing loan monthly, your salary fixed. So that is called this amortization schedule. So this amortization is the equal annual loan payment. That is what your installment, right? Necessary to provide a lender with a specified interest return plus repayment of principal. What your equal installment you are paying? The installment included your principal plus the interest rate to pay back to settle your loans. So how this loan amortization schedule is prepared, what concept is related? That is actually installment is calculated, housing loan, this mortgage loans based on the present value ordinary annuity concept. Normally we are paying at end of the year, end of the month or end of the period cash flows. So we are using normally present value interest factor annuity, present value of annuity, since periodic specific time period, present value annuity. At the end, so ordinary annuity. So if we take the example, 6,000 rupees payment, that is what you might use the word PMT, payment, right? What is your installment payment? That is called PMT or cash flow. 6,000 divided by, it goes for 10% rate of interest only for 4 years. It can be semi-annual, quarterly or monthly. Here it is considered as annual. So if you consider that factor at the 10% 4 years present value annuity, ordinary annuity factor is 3.1698. So 6,000 divided by 3.1698. So installment or payment, PMT, is your each year. Here this is annual payment for 1,892.86. Right? So I will explain this with the amortization schedule, how in the banks are preparing, how these amortization schedules are relevant. Okay. So this is more applicable. You can say, what is this amortization schedule? So this is the steps actually you need to follow to settle this or understand this schedule or preparation. You need to first calculate what is your installment. That is what payment per period. That is what we have done here with the present value ordinary annuity concept. You are whatever you 10 million you receive today from the bank, 10 million divided by present value annuity factor. Okay, that is your installment, periodic installment. This installment, say if you pay every month, then monthly payment, then what you need to do? You need to take this, your whatever this 6,000 rupees, here you need to divide by 10% by 12%, 12, that is interest rate, and n multiplied by 12, right? 10 years into 12, 120 times you are paying. Use the formula equation and you need to find what is the annuity, ordinary annuity factor for that and divide by that. Then you can find the monthly installment for that. Okay. So here I considered as actually annual, so I directly take it. So that is what this first step talk about, this installment calculation, PMT part. Second, we need to see how much of interest, how much of principal we are paying. So if you decide how much of interest for the period, so you need to take the loan balance on the previous period, that loan balance, previous period loan balance only. Say if you, how much is year 1 balance, you need to take year 2 as an interest payment previous period. I will explain with the number, it must be clear, T minus 1 multiplied by rate of interest based on year, whether it is monthly payment or annual payment, or then you need to take, that is the rate. That rate you need to multiply. That is, you can calculate amount of interest. Then how you can calculate the principal payment, compute the principal payment in today time period, today's period, how you can take it. So how much you pay this first payment, PMT, this calculated the installment, minus interest payment from the second step. That is your principal balance you paid as a principal. So next period, that end of that period, T period, what is your balance? After deducting the principal, you can get your balance to settle to the bank. So that is what you need to repeat it until you need to settle your loan. This is the steps that followed under the amortization schedule, what we are paying to the banks. So here you can see this example I take to understand these loan amortization schedules. So I take 6,000 principal, 10% interest, 4 years repayment period. I consider this for annual easy. Otherwise, if you go for semi-annual even, 8 times we need to calculate. Okay, right. So here, first we need to identify first step, what is the installment payment. So installment payment, I find it out here for 6,000, 10%, 4 years with the present value and annuity factor, 1,892.86. So we need to pay the loan payment each year. This is frequency is annual. If it is, you can imagine monthly, right? Monthly. So then this amount you have to pay. So you get the 6,000 rupees loan. So this much you paid as a loan payment at the end of the year. So year one end, after paying this, right? How much interest you paid out of this? 6,000 loan, 10%, 600 rupees, I paid the interest. Out of this 1,892.82, 600 interest, balance 1,292.82, I paid as a principal. So now how much of principal balance at the end of the year? 6,000 minus 1,292.82. So 4,707.18 is the balance in the end of year one. So in the year two, for this balance, I need to pay the interest. Installment is same, always same equal amount we are paying. So interest then 10%, 470.72. Out of this installment, then interest this much, principal is 1,422.10 I paid. So this principal I settled, then the end of the year two, our balance should pay to the bank is 3,285.08. So now interest in the year three, for this balance I need to pay. So 10%, 328.51. So principal then deduct from this 1,564.31. So again, we need to pay the interest and 1,172.08. So if you deduct this, maybe rounded errors can come. Other than that, there's no errors. We settle at the end of the fourth year all the money to the bank by installment of 4 years. What we receive 6,000, 10% interest rate. So here what you can observe, when the housing loans, when the amortization schedules, it clearly shows the beginning of the time we are paying more interest, over the time interest declines, but beginning of the time we settle less principal, over the time we pay higher principal. That is what once you are going to banks, bank officers are telling you, if you can able to pay within 1 year or 2 years, settle the housing loan. Otherwise, waste money for you since you almost paid your interest, only principal is deducting. Then you understand the concept now. Amortization schedule clearly explain that. What is this part? Okay, this is called actually loan amortization part. This is the schedule. Is it clear, students? Loan amortization. We will do the exercise, then that would be clear. Right? We will take the exercise page and do that. Right. Can you try first this question number 5, right? Bala won the state lottery. His prize can be taken either in the form of 40,000 at the end of each of next 25 years. One option, 40,000 at the end of each of next 25 years, or as a single amount, 5 lakhs paid immediately. So what if she expect to earn 5% annually on his investment over next 25 years, ignoring the tax, and which alternative should Bala take? Now we learned, right? There are 2 ways you can handle this question, right? So you first apply the present value concept and see what is your value, what is the answer, option 1 or option 2. Try the answer and update this answer for question number 5. Please find the answer for question number 5. What is the answer? Alternative 1, alternative 2. One is alternative 1, you can see how to do that. Alternative 1, you need to consider that is actually periodic cash flows. So you are going for 40,000 each year for 25 years at 5% interest. So if you calculate the alternative 1, what is the present value annuity? Right? Present value annuity for this alternative 1, right? What is the value? Equal cash flows is 40,000 rupees multiplied by, you can use the formula or you need to find the factor value, right? Present value annuity ordinary factor. I think maybe that table there is no 25 years. So you can use the equation and you can derive that value. So if you take that value, value is coming around nearly 14.0939. Is it correct? Anyone done it? Madhushan? Madhushan, are you here? What is the value today? This present value for this 40,000 single amount. 14.0939 into 40,000. 5 lakhs 63,756 nearly. But what is the alternative 2? You can see alternative 2 directly given in today's value 5 lakhs. This is, we use the present value, we calculated. Now you learned both, right? That is what I actually take this. Even other way you can do future value. How to do that? You can take this 40,000, taken either 40,000 after, what do you call, 25 years, how much of values? Okay? In the future value interest factor and how much of value. So then if you go for this 5 lakhs into 25 years with a 5%, what is the future value in 25 years? I take it time 0, today's value, and compare both alternative and you can recommend the higher alternative. Either of the way if you do, answer must be same. Is clear what I am trying to explain? Nayandara, is it clear?
Yes, madam.
Sabandi? Shashini?
Yes, madam.
Right. Inoka, is it clear to you? Inoka? Amit, is it clear?
Yes, ma'am.
Amit, yes, is it clear? Okay, right. So now I think we can come to the decision. Explain again how to get that. Okay, this is actually, you can go with your equation, right? So what you need to do, you have to use the present value annuity equation. This equation, since I didn't give the table actually, so you need to use the equation and you can get that. You can see that present value annuity, ordinary annuity equation, this equation. 1 minus 1 divided by 1 plus 0.05. Here it is 25. This is divided by interest 0.05. Then it comes as 14.09. Is it, once you calculated, it comes, Amit? I think who put the chat box? Okay, MBS 063, is it clear? Your chat box, you put the clarity. Madhushan, once you have calculated, factor is different. Clear, madam. Okay, right. So now shall we move to quickly do that amortization schedule question, and then we can wind up the class. Can you try this amortization schedule yourself? You can see here. Suppose you borrow, last question number 7. Suppose you borrow 2 lakhs. You are going to repay the loan by making equal annual payments in 5 years. This is annual payment 5 years. Interest rate on the loan is 10% per year. Prepare the amortization schedule for the loan. How much interest will you pay over life of the loan? So question is, how much of interest totally you paid for this 2 lakhs, 10% if you take the loan for 5 years. Prepare the table, amortization schedule, and let me update what is the total interest you paid for 5 years. Can you try based on what I explained with the table? Then we can discuss this answer.